Hi, this is Christian Cody, and this is my final project, Driving Route Optimization for a Multiple Traveling Salesman Problem. For my project, I chose to optimize a variation of the classic traveling salesman problem. In this problem, a salesman is given a list of companies and tasked with traveling to visit each of them. The problem is the list of companies is large enough that this will have to be broken into multiple trips. The goal is to find a set of driving routes between all the companies that minimizes the total time spent traveling. Such services as Google Maps could be used, but only for a limited number of waypoints per trip. As alluded to before, this situation is an extension of the classic traveling salesman problem known as a multiple traveling salesman problem. In this type of problem, consideration is taken for more than one salesman, leaving from the same origin, traveling to a unique subset of cities, and returning back to the origin. In our case, each salesman will represent a different trip. The motivation for this project was derived from a situation a family member of mine is currently faced with. Working in technical sales and based in the Chicago region, he is responsible for managing and traveling to a network of distributors. As shown in the Google Maps image on the right, these distributors are spread out across Illinois, Indiana, and Michigan. For the purposes of this project, we will take a set of 32 distributor locations and try to find an optimum driving route between them. All distributors must be visited in a total of 4 trips. A minimum of 7 locations will be visited on each trip, and no single trip shall exceed 20 hours of driving time. In order to produce a meaningful solution, accurate trip distance and duration values were necessary. A MATLAB script was written to query the Google Maps server via the Google Maps Directions API to retrieve driving route data for every possible combination of trips. This data set was then used to construct a cost matrix that would later be used to calculate the fitness of each generation of a genetic algorithm as a heuristic search method to find the optimal routes. All of this was implemented in a MATLAB script. The script was written such that the solutions found by the genetic algorithm would be presented in the form of several MATLAB plots of the locations and computed paths, as well as an auto-generated text file summarizing the details of each trip. The table on the right shows the results from 3 of the last runs. The objective here is to provide the genetic algorithm with an increasing amount of both population sizes and number of iterations to show convergence to the solution. From the table you can see the third and final solution was obtained after more than 6,000 iterations with a very large population size of 2,000. The next slide displays one of the MATLAB outputs, which shows each location in their respective number index plotted on a map. Note that the origin is marked with a star. All of the following maps were created using the MATLAB mapping toolbox. And finally, here are the results from the best solution. Each trip is listed on the table in the middle of the slide, and the map on the right shows the plotted optimal driving routes for each trip. These routes were included in the dataset obtained from the Google Maps Directions API and just needed to be decoded before plotting in MATLAB. The total distance traveled across all the trips is 2,505.6 miles with a total driving duration of 45 hours.